Hello. Hello, everyone. I hope you guys are hearing us okay. So this is our first live stream for 2020, and I'm quite glad that we managed to put it together. And considering the circumstances at this stage, we still managed to run our SecTalks. So here is me and Craig going to host our first live stream. This is our 55 session. So this is almost like 4 years we are running in SecTalks in Sydney. And like our usual meetups, we will start by giving you guys some idea of what SecTalks is, especially for the people who are new. So I got Craig to help me on that. Go ahead.
Thanks, Pedram. Hi, everyone. Thanks for joining the live stream. This is the first time we've run it completely live. We've done a few live streams before, as you've probably tuned in previously. So the good news is it means that we can bring SecTalks Sydney to everywhere, because for the last 12 months or maybe even longer, we've always had a full wait list and been at capacity. So the good news is we can reach more people doing it this way, and we'll probably do this until we can go back to the normal format. So what SecTalks is a monthly information security meetup group and networking event. Typically, the format is we have a speaker and then followed by a round of networking. So today is basically no different, except if you there will be no networking event afterwards, unfortunately. Cool. So yeah, it's not a vendor discussion or an advertisement. These are volunteer-led talks. All the talks are people from the community, so same as all of you at home. So if you ever want to present or anything like that, you can just reach out to us, any of the crew, and we can make it happen for you.
Perfect. And one more thing was we do run CTF events, and that typically runs in a separate days in a month. I think the upcoming one is scheduled for 31st, and mostly that will be an online event as well. So stay tuned for that. I should start by thanking our sponsor this year, Atlassian, continued supporting us, and a big shout out to the guys at Atlassian. Please do check out our meetup page on our Sydney page on sectalks.org for the link to a number of open InfoSec positions that they have. Now, I should say, like before live streams that we have, you can use our Sydney SecTalks channel to ask your questions, or you can also post your questions on this YouTube page. And right at the end of the talk, we will go through them, and Craig will help us for doing it. Now, yeah, let's just get to the talk. So today's presentation will be on password cracking in 2020 or why does this still work? It seems like during 90s, as our speaker put in, when he was a child, LM hashes were everywhere and Windows was not salting their hashes. And now in 2020, NTLM hashes are everywhere and Windows still does not salt their hashes. So this presentation is going to provide us with an insight into these type of hashes, and if you manage to get hold one of those, what you can do with them. Our speaker is a security consultant or penetration tester at PwC Sydney. I should say he helped us a lot, like similar to some of his other colleagues, to run SecTalks at PwC, and he really helped us to have this consistent access to the best meeting rooms possible and the catering. So a big shout out to him on that. And previous to PwC, he was the Director of Education for UTSC Sec. Now, without further ado, I would like to invite Rakim to go through his presentation today.
Hi, everyone. So let's start. So my name's Rakim, as mentioned. Two handles over there. And basically, password cracking 2020, or why does this still work? So, like, some people may be like, if you're a beginner, this will be very helpful. If you're experienced, hopefully you'll learn a trick or two. And you can also ask the same question: why does this still work in 2020? So let's go. Yep. So quick disclaimer: I accept no responsibility, duty, or liability for what you do with this stuff. So, and this is not professional advice, and not endorsing any product or service. The only two tools that are in here are both open source, so Hashcat and Pack. I'll go through them. So anyone can really practice. You don't even need a powerful computer. So the agenda today, so a bit about the historical past, what are password hashes, why do we care, how the heck do you crack them, the secret sauce, and what I think the future holds. So just a quick start off. This is a quote from Bruce Schneider. If you think technology can solve your security problems, then you don't understand the problems and you don't understand technology. Yeah, but I spent $500,000 on firewalls and AI, machine learning, and IoT. Good old Harold, poor guy. So I'm going to quickly skim through this, but this is all being recorded, so you can go back and I'll upload the slides as well. So don't worry, I'm not going to read the whole thing. But basically, the quick version is that we mostly got it right in the 70s, but we screwed up. So in 1960, a guy called Fernando Cobardo figured out that having every computer scientist at MIT have access to everyone else's file that was on the mainframe at the time was a bad idea. And he introduced the concept of using passwords. So each individual would have access to only their files during their allocated time period, because there was only one mainframe, a bunch of computer scientists, had to be some way that everyone could use the machine at the same time without, people overwriting each other's files, looking at each other's files. Funny enough, that's more secure than everything else that would be implemented for a while. So that was pretty interesting. It was loved because it was very simple to implement and very simple to use. And Cobardo himself would later regret that. So basically, if you think about it, your username, your password, that's it. It's like, oh, security solved. It was stored in plain text because hashing hadn't been invented yet, funny enough. Roger Needham and Mike Guy would later encrypt passwords using a one-way cipher, so hashing. Then Robert Morris Sr., sorry, I skipped ahead of myself. Robert Morris Sr. devised the concept of hashing. They just sort of use it as encrypted way of storing passwords. But anyway, the important part is in the 70s, early Unix systems decided that having a hash alone was not a smart idea and implemented salting so that you couldn't just pre-compute all the hashes to crack the password. Windows would not implement password salting, and they still haven't, except in the context of Kerberos, but let's just not talk about that nightmare. So what are password hashes? Password hash is basically a one-way algorithm that basically takes a string input, so your password, like password 1, and it transforms it into a hash representation. So if you think of people talking about SHA-1, bcrypt, MD5, whatever, you take your password like welcome1, changes it into a form that is not as computationally easy to determine without having the original password. Very important to know, though, that if you can reverse your hash, then you're not actually hashing it, but you're just encoding it. So if someone says, oh, I base64 the passwords, it's secure. No, it's not. But the salt is just a little random value that you add in while you generate the hash. Why do we do it? Is to prevent you from pre-computing every possible password possible, and then just really quickly be able to compare the hash to pre-computed and determining what the plaintext password was. I'll skip the little example down there, but basically this is an unsalted hash here, and this is a salted hash. So it's the same password. If I remember right, there should both be password 1, if I remember right. Even I don't know what the password is anymore. I think I left it in one of the notes and I've just deleted it, but it's all right. The main thing is that it was the same password, but when you salt it, it's not the same value as this value. That's the main thing to take away from this part. So now you know enough theory to sort of understand what we're about to do. You don't need to know any maths or anything like that. So the original quote from Bruce Schneider came from this quote from Roger Needham. If you think cryptography can solve your problem, then you don't understand your problem, and you don't understand cryptography. So I'm not going to mention the blockchain, but I just mentioned the blockchain. So these are the top 10 passwords. So I got these passwords from the Zynga leak that was on hashes.org. I'll go over hashes.org in a minute. You can download all the plain text found passwords already. You won't know what user, but you know the hash and the password. So then I just took out all the plain text and then sorted it, played around with it, and got the top 10. Interesting to note that password is still number 1. Yes. Interestingly, though, Hotmail 123 was the second most common. I was a bit surprised about that one. I didn't expect that. And then you have the normal 123s, the numbers, the words. So I'm guessing words with friends. I think that's owned by Zynga. I'm not sure. Someone can confirm or deny. Zynga 888, I guess they have a gambling app because 888 I think good luck in, I don't know which culture, but I think it means good luck somewhere. And then a few other passwords. So interestingly, of course, every time you see these top 10 passwords, the word password always appears. You can basically guarantee it. So it's a bit out there, for what I was trying to talk about. When I was getting feedback on what to do, people were like, well, how do you actually get the hashes? Well, here are some ideas. First of all, if you're on a network without encrypted traffic and NACT, you can just use a packet sniffer, man-in-the-middle connection, and sniff the credentials and get the hashes. Might just be in plain text or password, but hopefully it's hashed. On a Linux system, you would normally attempt to prevesc using common methods, so like plain text passwords in bash history, linenum, whatever, and then you grab the shadow file. But it's interesting to note and remember that if there's a web application like Jenkins running, you can spray your credentials against it. So maybe you can't get into the actual Linux box, but you can spray in through Jenkins. And if Jenkins is, for some odd reason, you get in that way, somehow you can pop a shell through there, you might be able to prevesc from there as well. Having access to a Windows system that someone's logged onto as a domain admin, Mimikatz away, DC sync the domain controller, works. You can use Responder. If you don't know what Responder is, I highly recommend at some point today, just like Google it, read up on how it works. It's so good still in 2020. Could be a whole nother talk in itself on why that still works. You'll get the NTLM v2 hash that you can then crack. And we're going to come to the cracking part in a minute. Kerberos, this also works. It's always effective. Highly recommended. You can spray and pray, so just pass the spray away. If it's a big company or a small company even, find it on Pastebin. You can find it on GitHub. GitHub's a great place. Find them when someone drops a database on Twitter. And just use your imagination. If you were time crunch sysadmin or developer, where would you drop your credentials? If you think of that way, you might find it. Or where would you leave your config files lying around? Maybe you're copying away. You're like, oh, I can't remember the directory. I'll just copy it to this folder temporarily that has world readable. I'll edit it and then I'll delete it. Never delete it. This is what Responder looks like through PowerShell. So this is through Inve, which is a way of using Responder on Windows. And the most important part is this nice little red box here. This is the NTLM v2 challenge response. You have this, you can crack it, or try to. So then I just wanted to cover one of those techniques I mentioned, which was password spraying. It's pretty straightforward. You have a list of usernames. You have a list of passwords. Usually just what you want common passwords, so password 1 with a capital P. Why capital? If you're using a Windows environment, a lot of times people enforce you got to have like one capital letter, one number. It's got to be 8 characters because it was a standard long time ago. I think NIST password standard long ago. So everyone's like, well, password 1. No one's ever going to guess that. Well, we can automate it, right? And of course, admin. So you feed in a list of users to a tool called crackmapexec, which is open source. It's on GitHub. You can just git clone it and run with it. Give it an IP range, username, password, and then you can tell it dump the hashes from the Windows SAM file, which is where Windows stores credentials from the machine. Of course, you can adapt this method for other tools. You could use Burp Suite. You could use really anything you want, as long as you have some way to feed in a username and password, and there's no sort of like capture or anything. Even then, you just spray away, and at some point, you'll get the hashes. it always works. Like, it always works. And again, that could be a whole nother topic. Why does password spraying still work in 2020? And that's what it looks like. Dumps the hashes. And then if you know Mimikatz, the old school LSA dump, DC sync, get hashes. So finally, how the heck do we crack password hashes? So my preference is using Hashcat, because that's what I used first when I was getting very serious about it. You can also use John the Ripper, but you might have to adapt the methods that are being used, but the underlying concept is exactly the same. So it has it's extremely optimized for GPU usage, and it's the fastest tool that I found for cracking with a very simple to use interface. That's all in beautiful command line, very easy to use. I decided that I might just show, I guess, what the command looks like. Be a nice reference if we go back to these slides later. So name of the tool, the command, hashcat -o -w3. A lot of times people won't include these, and then they wonder why it's taking forever. That was the first time I did this. I remember my senior was saying, why the hash is taking so long? I'm like, well, no, I'm using the GPUs. Like, if you've got the -o, oh yeah. Oh, you forgot that too. Oh yeah. So just don't ever forget about these. Just optimizations. -m. So this is the mode. So what type of hash you're cracking. So if it's Windows, it's going to be most likely NTLM. I don't think you're going to see LM nowadays, but you never know. Then you give it the word list you want to use. The order is really important. So if you ever decide you want to automate this, make sure in your script you have the hash first, then the word list or what you're going to use to compare it. Hashcat is very picky about this. It can't automatically determine which is what. So if you give it the wrong order, you'll spend hours debugging it. I've done it. It's very painful. And then -o. So this will save the output into a file. So originally I wanted to do the demos live, but with the whole live conference, I decided to record them. So I tried to make them very short, so I quickly go through it. Command, as I mentioned, it's exactly the same. And then when you run the tool, runs fast. It tells you a bit of what's going on. So how many hashes are feeding in, if you're using rules, which will cover, and other statistic stuff. So just to show you how good this is, I'm not using any fancy, 20 GPU crypto rigs. It's just Windows integrated graphics and then a 560X. So this was on my MacBook Pro. And then initializes, and then it starts cracking. And it's pretty fast. And it got 14. So I gave it just as a challenge for myself. I just downloaded a random list of NTLM hashes that hadn't been cracked yet. I just wanted to see if I could crack them while I was showing you. I have included some intentionally bad credentials, which you'll see in a moment. Right, so we'll go to the next one. Oops. Oh, it's begun. Yeah, there we go. So continuing. So what's wrong with this thinking of just like, oh, you can just automate. There's so many tools already do this. Why do we care about how to manually do this? Well, it's not the tool that's magical. It's the operator of the tool that's magical. So you're magical. So knowing how the tool actually works and what it's doing and what options are available will let you be more flexible and successful in cracking passwords. So this is what people think it's done. It's a bit of an assumption, but so people will get clone, let's say, hey crack from Trusted Sec. It's a great tool, but this is the mindset that they have. That, CD, Python, hey crack. Oh, here's the hashes. Here's the mode. Task 1, enter, done. I'm cracking passwords. I'm going to the pub. Go to the pub and come back. No cracked hashes. So then they say to their boss, we need more GPUs. It's always true. You can never have enough GPUs. The more the merrier. But it's not the problem at this time. Or just pass the hash. But let's just assume that the blue team mitigated completely. There is no passing the hash. You have to crack it. So have I been pawned? So if you wanted to if you've done password spraying before, you're probably aware. You've got a bunch of emails. You wanted to try people's passwords on like a corporate network. Have I been pawned? And if you do find them there and you want to have passwords to try, if you've got the leaked database or not, and you want to see maybe someone's already cracked the hashes for you, you can go to hashes.org. There is a section up here about lists, and there'll be a section called leaked. That's where the databases are. But for our purposes, if you want to have a lot more what I'll call wordless password candidates, which I'll cover in a bit. So if you know Rocky, it's a bunch of passwords that you can try against. I get much better success getting all the plain text passwords that have been ever cracked in hashes.org, combining them all into one big word list, and then deduplicating it. And I find it's really, really effective for cracking hashes. Like incredibly effective, especially when we start doing a few more things on top. So before we get a bit ahead of ourselves, 81% of breaches, according to Verizon, and from the 2018 report, involve credentials. So stolen credentials from credential stuffing and weak passwords. So, you know, you get a list of all the emails of a company, for example, let's say fakecompany.com, and then, you know, first name dot last name at fakecompany.com, and then you find like a web-facing login panel, and then you scrape welcome one, you get in. It wouldn't be a problem, except 70% of people reuse the same password or similar all the time at work, because all it takes then is if one account somewhere that you've ever used on like Neopets or RuneScape or wherever you want, and it gets leaked and they crack your password and use the same password everywhere, take that password, you know, go wild. And then you think, oh, but you know, we have password reset policies, and every 90 days you got to have a new password. You can't use your old password. Well, from my experience and looking around when people do this every 90 days or so, it take about a minute or less, because we just want to reset that password and get back to work. So we're not really thinking of secure passwords. We just want to do our work. So we just quickly, all right, you know, password 123, or you know, damn it, got to reset it. Password 1234, done. I mean, that's the mindset that's happening, and it's really hard to get people to change the way of thinking, because like if you think about it, it's like they've got so many other things to do. A password is like negligible in their eyes. And this is a little interesting password here. I don't know how many people will recognize what it is, but yeah, 1 CRAS, 2 WC, 3 EDC. It looks very secure, but if you look at your keyboard very closely, you might be able to figure out where this has come from. I'll leave it as an exercise for the viewers to figure out where it came from. And then 2020, just because. It looks very secure technically, but hopefully by the end you'll be like, eh. So the main part I think some people wanted me to get to. The secret sauce is 2020. Why does it keep working? Again, it is extremely, extremely common for people to use the same password or similar for nearly everything, myself included. It's just too hard to write passwords down everywhere, and then when you want to log in, you got to like look it up and put it in, and so just use the same one everywhere. And breaches happen all the time, and since the data is usually eventually publicly released, we can start using them as I use the word candidates here, but it's probably incorrect. You can, once you've cracked them, they become candidates to use for your stuff. Hashes.org is a start. As I mentioned, it is really effective, but let's say a user doesn't use the exact same password, or the system has some sort of password complexity rules, or they actually do make a new password for every site. Well, in my mind, there's 3 techniques and strategies we can use. We can use probability, common password patterns, and statistical analysis of previously obtained passwords. For the context of this talk, probability is the sense that people tend to think alike and use the same passwords as each other. There's a reason that welcome 1, password 123, spring 2019, winter 2019, whatever, always used, very commonly used in password sprays. Common password patterns is more like you need to, you know, meet a password complexity requirement, or you know, you need to think of a strong password. So you think, oh, my password is like, it's okay, but it could be stronger. Or just if I add some numbers and some characters, you know, now it's strong. No one's gonna ever guess it. And then we can also use statistics. So it's a bit of an out there thinking, but everyone thinks alike in a sense. So maybe people, when they think of a password, they use similar strategies. We'll cover it, so it'll make more sense in a few minutes. So we'll start with probability. So the easiest way of, instead of statistically analyzing all the passwords ever, Berserk 0 has already done it for us, thank goodness, and it's open source. You just download it. So he took a bunch of word lists from everywhere, and then worked out which passwords were the most commonly used from all these word lists, and then organized the entire word list in order of probability. It's really, really awesome. Highly recommend it. And I mean, storage is cheap nowadays. I mean, it is quite a few word lists, but once you have it once, you have it forever. So highly recommend it. From experience, if you have 2 or more modernish GPUs, so let's say 1080 Ti's and above, and a really quick hash, let's say, as mentioned there, the top 2 billion, along with hashes.org, using a rule like one rule to rule them all, which I'll cover a bit later, should do the trick, usually. If you have a slow hash, but not like really slow like bcrypt, the top 109 million and some tailor-made rules, which we'll get to in a bit, should do the trick. And if you're dealing with a really slow hash like bcrypt, the top 6 million, so the top 1% is a good starting point. And we're going to actually come back to that part in a bit. So when I mention password patterns, what do I mean? So let's take password 123 with an exclamation mark. If you break it down, password is just the word password with a capital P, right? So the capital P is, I guess, a difference for this word. 123 is just a sequence of 3 digits they added after the word password. So you take the word away, like just pretend the word didn't exist. You see the 123, and then the symbol added after the sequence, which is after the word password. So if you think about it for a bit, you're like, well, there could be a pattern here. And in Hashcat, it has something called a rule engine. So how Hashcat, when you feed it a word, let's say password, how it will modify it and then generate a hash to compare against the hashes that you have. So in its rule engine, and I would cover how to generate rules, but I'll just walk you through it because it's really vast. And there's a really good wiki on the Hashcat website, which covers it all. So I'd just be repeating the wiki, and that's no fun. It would be $, $1, $2, $3, exclamation mark. So the small u here means uppercase the word. So if you have a word like welcome, it will always capitalize the W. If it's already capitalized, it will leave it capitalized. If it's a digit, it won't capitalize a digit because you can't. It just ignores that part. $sign means at the end of the word. So if you have password, take the $1. You take the 1 and you just put it up there. And then it does it from left to right. So then it'll add the 2, it'll add the 3, add the exclamation mark. Hashcat already includes 64 of the most common rules found in the Hashcat directory, so you don't need to do it yourself. Funny enough, this is not included. From when I last do it, every few years they update what the top 64 rules are, so it always changes. There's also a much larger list of rules which have been made, which you can find on this link, which includes the one rule that I mentioned. And there's a really good blog post by Not So Secure, which covers the making of one rule, which I highly recommend. It's a good starting point to find common password patterns that may be in use. You can just add rules by doing -r and then the file in Hashcat, and feel free to experiment with creating new rules. Statistics. So there's this awesome tool called Pack, which I think not many people know exists. It's a shame because it's really, really good. If you always want to know about statistics of what passwords you've cracked, this is an awesome tool. Highly recommend it, and it's open source. It's ideal when you haven't made much progress and you think that people might have similar passwords, but you can't figure out what the pattern is. So what it'll do is it'll start sort of brute force the possibilities. This is what the commands look like. I'm going to demo the commands, so don't worry. This is just the context of what's going to happen. So just to run through it, it goes a bit fast, so I'll go a bit slow initially. So the two ran quite fast. I think we already covered it. So if you remember way back, we cracked it. I'm just showing what the passwords were. So you might see the theme here. So that's just from running RockU. So these are already in RockU itself. So it already has these Simpson-based passwords. The command at the bottom is what I showed before. It's just running the statistical analysis tool over these passwords. So we'll go pretty quick. But oh no, this looks really big. Doesn't look right. So the reason this happens is because, so hashcat by default outputs the hash and then the plain text password. So if you just try using it as is, you have to first cut out the hash and just leave the plain text if you want to use it for stat. So in this case, that's what I already did. So I cut it, and then now you get the pretty output. Oops, I don't know why it's stuck now. But anyway, I can do it in small screen anyway. So ignore this part here. What the main part you want to see is the password complexity of what you've cracked. So you can see here it says the minimum passwords found so far is 4 and maximum is 12. You could probably guess they haven't enforced any sort of password requirements. And the character set is all low alpha, which sort of adds to the evidence, and then the length of the passwords. That's pretty much what I was going to show here. That's pretty good. And those just from 14 passwords. The more you've cracked, the more, I guess, insight you get. Yep. And then this is generating the masks from using Pack. It automatically uses 1 billion hashes per second or keys or whatever, and it will optimize the order for you as well. So it works out if you give it an amount of time. So sorry, I didn't realize that little part that was cutting it. I don't know why I can't full screen, but doing it, you'll see it down here. It says target time 43200. That just means so it's in seconds. If I'm right, that's half a day, so 12 hours, and it will try to make as many masks or brute force candidates that it can for later. And that will cover 42% of the passes that you gave it. And it'll take about a year. So this is what a mask tech looks like. Oh, now it decides to buffer. Yep, okay. So ran really fast, but basically, yeah. Hashcat-O, W3, so optimized. A3 means you want to use the masks, the mask you generated. You don't need to go and filter through it. The tool just generates it for you. Those hashes, and then the mask file, so HC mask. And then passes it, does some little magic first, and then now it's cracking using those masks. So it shows you there. So $L means lowercase character. That's ASCII printable. So your keyboard characters, so the alphabet in lowercase for each position. So 1, 2, 3, 4, 5, 6, 7, 8, and there you go. So an 8 length password, it will brute force all the possible alpha printable lowercase characters. So instead of doing every printable character, you want to optimize it because it exponentially gets more difficult. And that just runs for a bit. We can skip ahead. You see it started to recover. So it was 14 before, now it's 15. And then I think it goes up to 16, yeah, and then finishes. But you go, all right, but let's just hypothetically say they're now salting the hashes. So Microsoft's like, all right, next Windows, we're salting everything. And we're not going to make it easy to crack. It's going to take some time. Drats. So what do we do? So what you have to do is you have to reduce the amount of password candidates. There's no other real way around it. But you can actually mutate them all in a similar way, depending on how the password is generated. So Adam, who's one of the main developers of Hashcat, created this mode called slow candidates. So it uses the rules on the potential passwords that you're going to use before sending it to the GPU. I don't know how it all works architecture-wise, but all that matters for us is that the hash rate is much faster. So the more GPUs you have, the faster you'll be. You can use Hashcat Brain. I don't want to cover it. It's a whole nother thing. And you can add probability. So you can use Prince. Prince is a great tool. I don't know how it works. I don't know anyone who knows how it works that I've met. So if you can figure out how it works, you've got a talk in itself. So this is what it looks like when you use it. I will cover the command, so don't worry about it. And the main thing you want to remember is the runtimes in seconds. So this tool prints, all you need to know is it will basically run forever. So you have to give it some point to end, because it just keeps generating new password candidates all the time. So instead of you having to find new word list, it will take what you have and change it around and then try to crack. So need more GPUs, of course. So where do you go once you've maxed out one of your server units? You don't go to data centers. Nah, you just go to a warehouse and get milk crates. It's the best way to do it. Highly recommend. So this is what Prince looks like. The annoying thing with Prince, well, the annoying thing with YouTube, it buffers. The annoying thing with Prince is that, again, it will run forever if you haven't given it a runtime. And when it starts, it looks like it's hanged, and you're like, is it working? Is it not working? Eventually, something will come up, and it just shows you how fast it's cracking and the process, the rate. So I've really limited to 15 seconds for the demo, and went to 18. So I didn't need to think of a new, word list or whatever. The tool just does it by itself. I had this error, and I thought it'd be interesting to mention it. If you're not used to using a Mac, not cut, but when you do sorts, they break. They don't work so well, and I was always stumped why it doesn't work. I'm just showing what passwords I found. So I'm making a little targeted word list here, and you get this illegal byte sequence, and you're like, crap, what's the solution? And turns out it's a locale issue. So for some reason, sometimes your computer will save it in like an ISO 80,000 something file. You just change the exports, and then it works like magic. So it works. And now we're all happy. But let's say now, you've done it, you got in, now you're coming back for like a repen test or whatever. Now they're using salts. Now they're using slow generated hashes. Now they're using 20+ character passwords. This is what it feels like. It's not a good feeling. It's terrible. But can we do anything? Oh, yeah, we can. So we found stuff from overhearing him. So you think it's all over, game over, we go home, cry. No. We don't give up, keep going. So just remember, they still take, most users, unless they've been trained, they're still going to take the 1 minute average. If we just tomorrow go, all right, we're going to enforce 20 character passwords on an entire organization. Well, it's not going to go down well, because people are going to be lazy, right? I would be lazy. It's probably what I'd pick. Password 1235, add more numbers, add more symbols, the quick brown fox, whatever, welcome at whatever. Just slam the keyboard a few times and get this nice, secure looking password. Do stuff like that. So what you'll also find a lot is repeated words. So if you say 20 character passwords, people are just going to use like password 1, because why not? Or they might use something that's predictable, so a street address, all the names of their kids, if they have kids, or their pets, the full name of the company, if it's like abbreviated, whatever, right? So you've noticed that this command looks awfully familiar, and it is, but there's an interesting file here called passphrases.txt. So again, someone else has already thought of this problem, and what they did was they took every song lyric from like, I think, Wiki Lyrics or something. They took phrases from like movie quotes and stuff like that, titles of books, put them all into one nice big file, and you can just use it, and it's free and open source. You can take this and then expand in it against what we covered before. So you can use the masks, you can use the rules. I would avoid the masks because it will take forever, but the rules are pretty good. And you can also start getting a bit more creative. So NetMukes mentions a few other attacks that I'm not going to cover here, but basically it's just playing around with word lists and stuff to get more password candidates. So the trick is, when it's a much longer password, you just got to get a bit creative and think of an individual. How would they think of password? So unless you train everyone to like think of randomly generated passwords, it's not, you're not solving the underlying problem, right? You're just trying to use technology to solve the problem, as Roger Needham mentioned. You can also use Prince, but for some reason you have to modify the source code and recompile it. But if you're at SecTalks, I'm pretty sure you'll be able to do it, I believe. So this has happened before. We've cracked some passwords, but we're not an admin or we're not the DA yet. We just start sweating a little bit. But if you remember PAC, just always remember StatsGen, which is one of the tools. Play around with the parameters, create your masks, and then just use the techniques we've mentioned before, and customize the rules. Maybe take some statistical analysis of the passwords you have cracked, whatever. Your imagination and the amount of GPUs you have are your only real constraints, really. For example, and I hope someone gets this. The company name is Compute Global Hypermeganet. You decide, well, you take the first letter of each word. Could that work? So you give it a shot. So as I mentioned, the dollars means at the end of the word, just throw some characters on there. The U just means capitalize capitalize the word. T1 means toggle case. So if the letter's already capitalized, it will uncapitalize it. And then these hats here just means add it to the beginning of the word. And the annoying thing is you have to because it's going to go in the beginning, you have to reverse the string. And yeah, it's a bit annoying. So if you run the techniques I mentioned before, you'll see that from my example, you'll find a bunch of cracked passes which have a strange sequence. And I'll show you this in one bit. You take these passes and you feed them into the tool PAC. With the mask attack, you'll crack over 80% of the uncracked passwords. Not true, because at the last minute I decided to throw in another 70,000 random hashes. Why not? Turns out they were made by a password generation script made by the first sysadmin, which was Homer Simpson, of course. Creating the custom masks. So if you remember, we took all the cracked passes we had before and we made a targeted word list from it. And basically we just trained the mask, some statistics, and then the character sets. So again, lower alpha, and then lower alpha with numbers with the occasional capital. And then just a bit of the complexity rules. All that's fine. And then you generate 25 masks. And it'll take remember right? It's 1 hour. So it's pretty good. We create the custom rules. So this is going to go pretty quick because I already made them. I've just put them in a text file, and I'm going to use them. So I took the best 64 rule I mentioned before, took custom rules, put it into one file. Now I'm going to run prints. I'm going to use this tailored word list I made and the custom rule that I just made. And yep, so that went really quick. So let's see if I can get over. Oops, let's see if I can do it. I believe. All right, so full screen works now. Cat word list. You pipe it into the prints tool because that's just how prints works. You pipe the output of this into hashcat. So if you've noticed, I haven't given it a list of words. You can pipe input into. You can pipe your output from whatever you're doing as an input into hashcat, which is really useful because you do not want this file to be pushing stuff onto your storage devices. You will run out because it goes forever. And then runtime 15 seconds. I did not know what was going to happen when I ran this because there were 70,000 other random hashes from some dodgy website, and they were not cracked yet. So no one else has cracked them so far. So I'm like, well, we'll see what happens. Again, that dread in your heart to see if it's going to work. It worked. It got 38. So it went from 18 to 38. Let's see, this is a good feeling. And it reached the runtime limit because I only set 15 seconds, and then it got to 41. And then, of course, that sweet victory. Just getting a list of passwords. It's the greatest feeling in the world. See, Barney, however, I don't know, it's, Simpsons, right? And if you look carefully, you start seeing these passwords with this weird pattern that we mentioned before. So that rule we made before, right? Of course, Homer decided to use it everywhere. So, of course, it's made sense that if we have it as a rule, when we go through the words that we give it, at some point you might find the correct password. The fun part was I didn't add this password. I don't know where it came from, but it just worked and got it. So I was really happy about that by cracking random passwords. And yeah, it found these other passwords. I have no idea what they mean. But I was like, yeah, it's a good feeling. So yeah, thought it was pretty cool. So that's a lot to take in, I can tell. But it's okay. Again, you're going to have the slides, you're going to have the presentation, and if you go through it, you'll get it. Once you know it, you pretty much know it forever. It'll take you at most 1 to 2 days, and it'll work forever. I mean, it's been working since the 90s. Doesn't look like it's going away anytime soon. So, in conclusion, if you've forgotten everything I've mentioned, just remember this one fact, this one thing. You got to stop only using passwords. Just remember SOUP. Stop only using passwords. And start enforcing MFA instead. So multi-factor everything. Only around 20% of organizations that use Office 365 are using MFA for the user and admin logins. And if you've used Office 365, you know it's accessible over the internet. Just 20% are using MFA. So 80%, the vast majority are not using MFA for the users and admins. And that's the source. So I didn't just make this number up. So it's the humans. We're the problem. We usually are the problem. But it's okay. There is hope, maybe. So what do I see as the future? Well, I've got two views. We'll start with a dystopian future where nothing changes and we just keep going on the path we are. You know, we have like password one everywhere. You know, you get onto a domain, you get onto an internal network and you just spray password one, get in, welcome one, spring 2021. I mean, spring 2036 at some point, it'll probably still work. And, you know, nothing changes. We keep buying new boxes and, you know, everyone says it's more secure, but sprays still work. Windows doesn't salt the hashes. But there's a utopian future in the end, right? This is what I hope happens. We need to possess something as a separate factor in addition to knowledge of a password. YubiKeys and other tokens flooded the world. Vendors implemented it. NIST and PCI added it to their goals and made it a minimum baseline. And the most important thing of all, there was budget. Yes! So everyone implements MFA that is not through SMS on all their endpoints and don't miss anything. This also implies that you know where everything is, which again is a whole nother problem, which would be a great talk. If someone can solve this problem, you'll be bald, I can tell you right now. Passwords not being stored in logs and not being sent to a SIEM, hint, hint. Privileged access management, so handing out access to accounts without you and your machine having the password or hash, and then rotate the password after use. You can use whatever you want, as long as you're using something at some point. Log into your PAM solution is a passphrase because you need a password somewhere at some point. That's also backed by MFA, so don't just use welcome one, right? Don't defeat the whole purpose. Password managers are being used for websites or OAuth 2.0, single sign-on based solutions. I know having Facebook have the power to log into anything that you have is a bad idea, but as I tell my mum all the time, I'm like, Mum, what would you pick as a password? And she always says, I'd pick your name. I'm like, please stop doing that. So I'm like, just use Facebook, sign in. It's more secure. And Facebook's pretty good at when you're trying to log in from weird locations, it does ask you to validate. So it's better than nothing. I think it's way better than what people are using now. But of course, if you're a bit paranoid or you don't want to trust Facebook with your data, or Google or wherever, you can use a password manager. So I use KeePass myself. Once you get in the habit of using it, you just pretty much keep using it. Mac has Keychain, Windows, just use LastPass, KeePass, whatever you want. You can get it on your mobile too, so that helps. I've managed to teach my dad how to use it. So if my dad can use it, anyone can use it. So just believe. User education and a culture around being vigilant about security. This is not just the, beginning of the year, you got to do your mandatory training if you work in corporate. If you don't, when you do, you'll know what this is. But instead, everyone sort of works together instead. And security becomes everyone's problem, not just the tech people who are already overloaded with 20 other things, including printers and whatever. The blue team are aware of weaknesses of using passwords and are monitoring for any suspicious activities which may indicate threat actors on the network. So not just like pumping in a bunch of Yara rules and be like, well, we just keep updated to all these threat feeds and we'll get there. But missing the obvious, few hundred, incorrect, invalid logins from like 100 random users, all within like a certain space of time or whatever. And then a small thing about zero trust networks. So if you've heard of the Beyond Corp model, maybe useful, maybe not useful. I don't know. I don't have all the answers, but I'm sure if we all work together, we'll get there. Surely we can't do worse than what we are now, which is Windows not salting their hashes. If anyone here knows how to get Windows to salt their hashes or can pass the word up to whoever push on salting passwords, go for it. Any questions or hashes you need cracked? Let's see if I can find them. Sure, if someone wants to jump in and read something to me.
Well, thank you very much, Hakeem. It was an interesting talk. Lots of info, as you said, and also the workshops, those demos were also quite interesting. Well, if anyone has any questions, now is the time you can ask them on the channel, and we will go through them.
The first one from Skorov. Now that WeLeak info is gone, what do you recommend as a replacement?
Oh, I use, there's some people have their own databases, but I think there's Dhashed, but I haven't used it. I liked WeLeak info. It was really good, really sweet. It was no surprise that it was going to get taken down. Like, you just made it too easy. I think Dhashed, but I haven't used it, so I can't recommend anything. But a lot of people just build their own databases. So if you've heard of LeakDB, people just start from there, and start whenever Twitter. They stay on Twitter and Reddit, NetSec, and then the second a database drops, they grab it and then build the database from there, because those leaks don't last forever. Those links will all go down one day. So that's how people do it. People like Dhashed and stuff like that, I guess, do the same thing.
Excellent. The second question is from Miriam. What are your thoughts on tools like Bitwarden?
I haven't used Bitwarden, so I can't say. So I feel like I should search what that is. Bitwarden. Right. Oh, open source password management. So anything like that. Anything like that, I think, is a good idea. Any sort of password manager. I think there's Vault as well. People use in corporate for credentials, if I'm right, off the top of my head. But anything that's not just remembering all the passwords is good. I mean, it has to be better than what we're doing now.
I've got a question from Delta. Rakim, do you usually go straight for the passwords when hunting for DA or domain admin, or do you try other avenues first?
I feel like I'm giving it away, but I mean, it's no surprise. Kerberos, crack the password. One of the service accounts will be DA, usually. I've seen it nearly everywhere. Yes, password's the easiest way. Not always. Sometimes people leave their creds on GitHub. And I know it sounds funny, but it's there. Trust me, it's there. If it's a big enough company, it'll be there. But passwords are why try to work out a 0-day or throw a Metasploit payload, which will get picked up by the seam, when you can just password spray in or find password wherever and just use that, because it's successful login. So nothing sus. And if you think a little bit okay, it's an Australian company in Sydney. Can I get a IP from Sydney in Australia? And if I log in at a normal looking time, maybe at lunchtime, is anyone going to even notice? Well, first of all, you're assuming that the SOC's looking anyway. But if you do that, how are you going to detect it? I don't know. If anyone's got the answers, I mean, let us know.
Any other questions from anyone? Well, I think it's already 56 minutes to this live stream. I think it was a good try for the first time, I should say. If there is no other questions, we just conclude here. And thanks to, first of all, to Rakim to join us. Thanks for the talk. Thanks for going through it. I know it feels quite different when you do it live. You don't get that much feedback. It's same to me. I think Craig as well. You don't really see people to see what's their reactions are. And yeah, so please stay tuned for 31st of March. We are going to have our CTF nights, and obviously that's going to be online as well. If you have any comments or feedback for this live stream, please do let us know. If you would like to join our Slack channel, sydney@sectalks.org is the email you can use. Well, that is all. Thank you very much, and see you next time.
Password one. It's always password one.
All right.